So what are the group 14 elements? Tell me fast. See, there is a question they will be making like this. Element. Listen, I am making a question. See, there is an element with atomic number 113. This element belongs to which group? Which group? How you are saying? Your answer is correct, but I don't know how you are saying. See, just what is the 118th element? 18th group, na? Yeah, come like that. Come back side. So it is 13. Perfect, perfect. What is the answer? 13th group. Okay, next. So 114th element, fluorovium, belongs to 14th group. Okay. So now periodic properties. First one is atomic radius, down the group size increases now. So like that, atomic radius, ionic radius, atomic volume, atomic density and electropositivity. All these things down the group what happens? Increases. Okay. Once again look into this. All these things are increasing down the group. Next. Next one, ionization energy. So down the group what happens to ionization energy? Decreases. So there is no change here, decreases down the group. Next, what about electronegativity? This is also decreases, we know, but here silicon, germanium, tin are having almost equal electronegativity, that is almost around 1.8. What is the value? 1.8. Okay, so first one, which is highest one? Carbon, around 2.5. Then next, lead. Sir, why lead is having more means? Due to lanthanide contraction, that F orbital is involving now. So now what happens due to poor shielding? That nuclear forces acts up to the nth level. So positive charge only in nuclear force means that will drag the electrons. That's why its electronegativity is highest here. So what is the first one? Carbon. Next, lead. Remaining three are having equal electronegativity values. Okay. The next one here, melting points and boiling points. So down the group, melting points and boiling points decreases. See, melting point is decreasing down the group. So tin will be having greater than this lead. So it means this is the least one. You put here like this. So what is the order? First carbon, silicon, germanium. Here it should be tin. Bring it this side. Lead, tin, like this. Okay. This is what? Melting point. So boiling point changes in oscillation way. Oscillation way means increase, decrease, increase, decrease, like this. So first increase, next decrease, again increase, next decrease. Okay, write these two things first. Okay. Okay, before going to oxidation states, see, which family we are talking about? Carbon. So carbon carbon bond, silicon silicon bond, next germanium germanium bond, like this. Like this, if I take, which is having greater enthalpy or bond energy, I am asking. So down the group bond energy decreases, remember. So which is highest one? Carbon. Next this one, like this. Write that order. Include in your books this order. Alright. Okay, next one, oxidation states. So what is the minimum possible oxidation state? It is -4. For example, methane we are writing now. So in methane, what is the oxidation state of carbon? -4. Okay, if you are writing CO2, what is the oxidation state of carbon? +4. So minimum is -4, maximum is +4. Okay, so now the most of the compounds. For example, if I only use this NP2 electrons for bond formation, what is the oxidation state we will get? Like carbon monoxide, like this we are making. So here it is how much charge it will be having? +2. Okay, if I use all these 4 electrons, it will be +4. Like CCl4 if you take, it will be +4. Okay, so these are the two possible oxidation state with 2 electrons with 4 electrons. Now out of these two, which is more stable, they will ask. So now what happens down the group? Higher oxidation stability decreases. It means +4 oxidation stability down the group decreases. So that is what the order here. So lead with +4 oxidation state is unstable. Which one? Lead, because this is the bottom element now. With +4 oxidation state it is unstable. Remember these two orders. So it means what is the stable oxidation state of lead between Pb +2 and Pb +4? +2. So like this is the stability order now. So now what this lead will do, if it is present in +4 oxidation state, it tries to convert from +4 to +2. For example, PbI4 is there now, PbI4. What I am saying? PbI4. So what is the oxidation state you are seeing? +4. So it is unstable. Now how it will try to convert from +4 to Pb +2, like PbI2 plus I2 gas will be released. So I mean this will be formed. So +2. So because of its instability, converting into this form. Okay, is this clear? One more thing. Now they will be making a question here. Pb +4 compounds act as an oxidizing agent or a reducing agent? Because these will undergo reduction, oxidizes others. So Pb +4 can act as a oxidizing agent. Remember this. Okay, we have a EAPCET question we will do after some time. Okay, have you written these two orders? Okay. So they will make a question like this. GX2, SNX2, it means halogens, consider, X means. Next PbX2, which is more stable, they will ask. Like this? Okay, otherwise I can make one more question also. GEO, SNO, PbO, which is more stable, they will ask. Why? It is purely based on what? Their oxidation states. Okay, like this you can write. Is this clear, everyone? Okay. Done? Yeah, let's move on. So what do we mean by catenation? Like carbon making large chain now. So that is nothing but carbon-carbon self-linkage we are saying now. So ability to form self linkage is considered as catenation. So catenation tendency is highest for which one? Carbon. So down the group that catenation tendency decreases. So first carbon, silicon, these two are having almost the same, least is lead. Okay. Can write that. Next, chemical reactivity. So let us consider this group 14 element as M. M upon exposure to air, oxygen, forms two types of oxides. What are those two? Either MO oxide or MO2 type oxide. So MO oxide means here +2, here it is +4 oxidation state. For example, if it is carbon, we are going to get carbon monoxide. Here it can be carbon dioxide. So like this, if it is silicon, you are going to get SiO, it is SiO2 type of oxide, right now? Like that, we have this many types of oxides. Okay, so now what happens down the group electronegativity values? Decreases. So if electronegativity decreasing, acidic nature also decreases. For a particular oxidation state, if electronegativity of that elements are decreasing, acidic nature also decreases. Simple. Non-metals form acidic oxides, metals forms basic oxide. Already we discussed the same statement morning. So that's why carbon is a non-metal now. So here it is neutral. First one, what I am saying, it is neutral. If we go down the group, what they are becoming? Amphoteric. Still if we go down, it becomes basic. But all of these are what? Amphoteric. Remember this. See, only like monoxide which is neutral is which one in the 14th group? Carbon monoxide. Remaining all monoxides are what? Remember, we can make a question on this. Okay? Right. Next, this one, carbon dioxide and silicon dioxide are acidic, remaining are amphoteric. So it means in 14th group oxide there is no basic oxide. All of them are what? Neutral, amphoteric, here acidic, amphoteric. So there are two statements. See, CO I am writing, CO2 I am writing. What is the oxidation state here? +2, +4. Where do we have more oxidation state? So as oxidation state increases, acidic nature also increases. That's why carbon dioxide is acidic oxide, carbon monoxide is neutral. Okay, you make these two statements in your book. Okay, anyways tomorrow we are going to discuss about nitrogen family. There also this statement are useful. Now itself you tell me, I am writing NO and NO2. Which is acidic oxide? Stronger acidic oxide? NO2. Here this is a neutral one. Remember, NO is neutral. This is acidic. Okay. One more also I am adding. N2O5 also I am adding. Check their oxidation states. +2, +4, +5. Higher oxidation state, more acidic. Is this clear, everyone? Yeah. So once again tell me, what are the neutral oxides? Only CO. What are the amphoteric oxides? All monoxides except CO. Next, this side dioxides except CO2 and SiO2. Remaining all are amphoteric. Perfect. Okay. Between CO2 and SiO2, which is stronger acidic oxide? Which is more acidic oxide? That's why I told you to write these 2 points. More electronegativity? So between SiO2 and CO2, which is having more like both of them are +4 oxidation state. Now look at their electronegativity. Carbon is more electronegative now. Down the group, what happens to electronegativity? So carbon more electronegative means more acidic. When you are writing something, try to understand what is the meaning of that line. Over. Next. When carbon is treated with water, so it will form CO plus H2. So this mixture is called synthesis gas. What is that? CO plus H2 gas is called synthesis gas. Okay. So now if we go up to lead, so lead won't react with water. What I am saying, lead won't react with water. It means why it is not reacting, like morning class I told you about aluminium won't react with nitric acid. Why? It is forming a protective layer now. Similar to that, lead also forms a protective layer. Further it won't react. Okay. So due to formation of protective oxide layer, lead is won't react with water. Okay. Next, reaction with acids. So when it is carbon, when it is reacting with like acids like sulfuric acid, forms respective oxides. There also 13th group also, boron upon treating with acids will get oxides. Okay. Here also we are getting carbon dioxide. So here carbon only react with concentrated acid due to strong CC. It means this carbon only react with water. It requires strong concentrated acid. If I do it with dilute acid, carbon will react or not? No. It requires what? What is the reason for that? Just now you have seen enthalpies. Highest enthalpy, bond enthalpy is for which one? CC bond enthalpy is more now. In order to break these bonds, we require stronger acids like concentrated acids. Okay. Other elements can react with dilute and concentrated both. From Si to Pb, reactivity increases. It means which will react easily with the acid? Lead. Okay, write these statements. Done? Done? Done with this? Okay, next. Reactions with halogen. See what they will form? Like MX2 type compounds and MX4 type compounds. What are the two possible things? We can get either MX2 type or MX4 type. So MX2 type stability down the group, what happens? Increases. MX4 type decreases because of what? Inert pair effect. Most reason is inert pair effect only when they are asking about stabilities for compounds. Okay. So this is the order of the stability. See, already we have discussed about PbI4 story. What I told you, PbI4 is unstable because of higher oxidation state. So what it will do, it will decompose as PbI2 plus I2 gas. Over? Okay. Next one, I have same element. Let us fix this M as any of the 14th group element like carbon or silicon like that. I am changing the surrounding atoms, fluorine, chlorine, bromine, iodine. Same story we discussed there also. So now what happens if I change the halogens? Small size halogen is there now. That compound will be more stable. So stability down the group, it is decreasing. I mean down the group means for fluorines, I mean halogens. So M4 type is more stable than MCl4 type. It means you take anything like this, SiF4, SiCl4, SiBr4, like this if you take, which is more stable? Like this. Done? ఇక్కడ ఉంది. Next, is hardest substance now, that's way. Next, graphite. So carbons are what? sp2 hybridized. See, it has hexagonal rings like this, like benzene rings are there now, like that. Like this, layers will be there. Like this, layers will be there. Okay. So now, what I am saying, they contains what? Pi electrons like this in all these rings, condensed rings. So due to the mobility of pi electrons, graphite show conductivity. What it will show? Conductivity. Whereas diamond, bad conductor I am saying, because there is no pi electrons or nothing to move here and there now. But in this case, in graphite we have pi electrons, because in carbon, again carbon is attached with the 4 other carbons like this. Is there any free electron here? So that's why it's a bad conductor. Okay, here pi electrons are there. Okay, now one layer here, another layer here. Between these two layers, van der Waals forces will be there. Okay, so due to that reason only, we will see graphite is a slippery nature. When you touch the pencil needle, you will feel like a lubricant, like an oil, greasy substance. So what is the reason? Because between the layers, There is van der Waals forces which are weak, that makes it to be slide. Okay, so due to that reason it is used as a lubricant. Which one? Graphite is used as a lubricant at higher temperature, because at higher temperature oils won't it won't work efficiently now. That's why we are using graphite as a lubricant. Okay, and which is more stable? We'll say it has a thermal stability. So which is more stable? Graphite then diamond. Done. One last discussion. Wait. Already we discussed about fullerenes in the morning class. Done. Okay. Over. Next. So fullerenes, what I told you, graphite upon strong heating it gives a soothy material, mainly contains C60, C70, CIT, like that. So how these C60 compounds will be formed? They contains what? They composed of hexagons and pentagons. What is the pentagon number? Pentagon number is fixed as 12, but hexagons changes by formula to formula. Okay, so I told you one formula, that is what Euler's rule will say, n minus 20 by 2. So that n value should be greater than 22, then only this will work. Okay, so n minus 20 by 2. So for hexagon, C60, how many you tell me? How many hexagons? 60 minus 20 by 2, 40 by 2, 20. If I say C70, 25. Morning we did this. Okay, done. So now let us see some questions. Okay, right. Okay. Right. Atomic density down the group for 14th group elements. 14th group elements density down the group. Density increases. So which is highest? Increases. Density what happens? Increases. So which is our answer? Lead. Next. This one we did morning only. Next. Silicon 4 chloride, it means SiCl4 upon hydrolysis produces an acid X. So X contain number of OH groups. How many? So how many chlorines are there, ma? This is important question. I will make one more question on this. OH. So how many OH groups are there? So you can call this compound as a silicic acid. What is that? So it can able to release all 4 hydrogens. Okay. So now how many H plus ions gives an acid gives X number of OH groups. How many OH groups are there? 4. So what is your answer here? 4. Next. What about this one? I know you can answer this very easily. First of all, which group elements? 14th group. So they are saying about Sn plus 2 and Sn plus 4, and next Pb plus 2, Pb plus 4. We know Pb plus 4 is unstable. So now what it will try to do? It converts from here to here. So what is that nature? It is undergoing reduction, oxidizes others. So I can say oxidizing agent. So now look at the options. Where do we have Pb plus 4 as an oxidizing agent? As an oxidizing agent, oxidizing. Next one, Sn plus 4 is a reducing agent. They are saying it as a reducing agent. See, if this is a reducing agent, it should reduce others, it should undergo oxidation. Is it possible for this to undergo oxidation? No, it means this is incorrect. Next one here, Sn plus 2 is a reducing agent. It means it will reduce as others, oxidizes itself from Sn plus 2 to plus 4. This is possible. So what is the appropriate answer for this? Third one. Is this clear, everyone? Yeah. Next. What about this question? Aluminium reacts with dilute acid, liberates a gas A. With aqueous alkali liberates a gas B. What are these A, B's they are asking? The morning class we have discussed this. What is the answer? No. Aluminium react with HCl. So now what happens? See, metals upon treating with acids releases H2 gas along with formation of salt like AlCl3. So what is the gas released here? Even aluminium upon treating with base NaOH, here also it forms like morning aluminate, meta-aluminate, something like that we discussed. Okay, along with that H2 gas is released. So Na2AlO2 plus H2 gas will be released. If you see the morning class notes, it will be there. Okay, so what is our answer for this? Okay, clear everyone? Okay, still this is done and I will show you few more questions. Wait. What is the answer? See, they are saying dioxides, monoxides of element X, this should be dioxide. For element Y it is monoxide. Monoxide, it means Y type. Dioxides, monoxides of elements X and Y are amphoteric in nature. So what are these? Dioxide should be amphoteric. For which one? See, for dioxide, silicon dioxide, if I say, what is this? It is an acidic. If you check, CO2 and SiO2 are acidic, I told you. But it should be amphoteric only. It can be shown by this one. Okay, it can be shown by this one also. Monoxide also. So what is your answer for this? Sn and Pb. Okay, next. Next this one. What they are saying? dioxides and monoxides of element X and Y are amphoteric in nature. See, dioxides and monoxides of elements X, you take both of them and also XO, YO and also YO2. Both should be what? Amphoteric in nature. First one not possible, second one not possible. So for this you tell me. SNO, SNO2. Next PBO. All of these are what? Amphoteric, amphoteric. This one GEO. Okay, this one also perfect. Both of them are perfect. So you can go with both options. Carbon, silicon, germanium, tin, lead. They are saying basic. So both of them are correct then. So you can choose any of those. Okay, because both of them are giving amphoteric now. So both of them are correct. Next, this one. So beryllium hydroxide. Tell me for this one. So OH minus you are giving this side. How many you can give for this? So it can show tetravalency maximum. It means 2 OH groups are there. How many you can give still? Like this. Okay, they are asking covalency. How many bonds beryllium and aluminum can have? Next, same with this one also you do. See, 6 they are saying 6 is not possible with the beryllium. 3 they are saying 3 is not possible with the beryllium. So out of these 2. So now with aluminum you check. So it also makes 4 bonds. What is that compound like Al, OH 4 times. Okay, with minus 1 charge. Okay, so 4 and 4. What about this answer you tell me? Atomic radius of gallium is less than that of aluminum. Morning class. Poor shielding of d electrons. Okay, option C. Next one, this one. Melting point. Just look at the order that you have written just now. Just now you have written, ma. This one like that I told you to put this at the last. So what is that? Tin. Next. This one, morning class. Following statements and correct one. Pick out the correct options. Incorrect options they are asking. So AlCl3 gets stabilized by forming dimer. Morning we discussed. Next, BCl3 has electron deficient. This is also correct. First 2 statements are correct. See, this is reduction potential or oxidation potential. +3 converting into 0 means reduction. See, reduction potential should be negative for metals. They mentioned it as positive. So it is incorrect. For aluminum it should be negative value. So this is incorrect. Next, in +1 oxidation state, thallium is unstable. It is stable. So what are the 2 options incorrect? CD. So option 1. Okay, all these are clear. That's, you can practice if anything remaining.